Hello students, this is Jagan Babu, Assistant Professor, Department of ECE, RMD Engineering College, Kavarapete. Currently I am handling this subject, Digital Signal Processing, Lab Integrated subject, for third year, even semester, that's a 6th semester subject. Though one of the very important subject, we have n number of projects based on the MATLAB or Arduino, or they can go with a processor. 22EC601 Digital Signal Processing. Today going to see on unit number 3 FIR filters. FIR filter full form is Finite Impulse Response Filters. For any kind of filters, it should be in a finite sequence. Desired response will be the finite sequence. That is nothing but FIR filter. The topic going to discuss today FIR filter is phase and group delay problem. Very, very important. The students will not check over this kind of the problems, though they will see only the window type problems, frequency sampling techniques problems instead of this. Question: find the phase and group delay and also determine the frequency response of the FIR filter defined by y of n is equal to 0.25 x of n plus x of n minus 1 plus 0.25 x of n minus 2. I'll repeat the question. The question will be: find the phase and group delay and also determine the frequency response of the FIR filter designed by y of n is equal to 0.25 x of n plus x of n minus 1 plus 0.25 x of n minus 2. How to solve this problem? Solution. First find the transfer function h of z. H of z is equal to y of z by x of z. For given question, apply the z transform. Y of n becomes y of z. Y of z is equal to 0.25 x of z. Z inverse x of z. 0.25 z power minus 2 x of z is equal to y of z. After finding this y of z, in the RHS part, take x of z outside. Therefore, y of z is equal to x of z once taken outside, 0.25 plus z inverse plus 0.25 z power minus 2. Once you got x of z, this side is y of z, LHS. So y by x you know very well h of z. Therefore, h of z is equal to y of z by x of z. Therefore, 0.25 plus z inverse 0.25 z power minus 2. One of the basic advantage for the FIR filter is we don't have any poles, only zero terms. After finding the h of z as 0.25 plus z inverse plus 0.25 z power minus 2, change into the frequency term, that is the e power j omega term. H of e power j omega, h of z is equal to e power j omega, it is a discrete Fourier transform. H of e power j omega is equal to 0.25 plus e power minus j omega plus 0.25 e power minus j omega power 2, it becomes e power minus 2 j omega. H of e power j omega equal to 0.25 e power minus j omega plus e power minus j omega plus 0.25. I am arranging the term normally. Therefore, I need to calculate the frequency response. For calculating the frequency response only, I calculated the h of e power j omega. H of e power j omega is equal to e power minus j omega term in the RHS part I am taking outside. E power minus j omega, once I taken the outside, I am getting the bracket of 1 plus 0.25 e power minus j omega plus 0.25 e power plus j omega. Because I am already taking e power minus j omega term, no? So it means that 0.25 term that is consistent of single value. So based on the single value e power minus j omega and the e power plus j omega, its value becomes 1. Now I am going to calculate the group delay. Group delay formula is tau g is equal to minus d by d tau into theta of tau. But theta of tau is nothing but minus omega. Tau g is equal to minus d by d omega into theta of tau. Therefore, minus d by d omega, instead of theta of tau, I am substituting minus omega. Therefore, a differentiation of omega with respect to d omega becomes 1. Therefore, it becomes tau g is equal to plus 1. minus into minus plus. I repeat again, tau g is equal to minus d by d omega into theta of omega. Theta of omega is nothing but minus omega. It is e power minus j omega, it becomes minus omega. So I am substituting minus d by d omega of minus omega, minus into minus plus, differentiating with respect to omega. Already omega term is there, omega into omega 1. Therefore tau g is equal to 1, which is nothing but group delay. Next we will see about the phase delay. Tau p is equal to minus of theta of omega by omega, which is equal to, already what is my theta of omega? Minus omega. So minus minus plus, so omega divided by omega. So omega by omega get cancelled, therefore 1. Therefore tau p is equal to 1. This is the phase delay. So we have calculated group delay and we calculated the phase delay. Sometimes they are asking in the 2 mark problem also. Thank you students. More videos we'll see in the next